Hello! I created this channel to introduce beginners to programming. This tutorial is for people who have no experience in how to code and are struggling to figure out where to start. If you would like to follow along, the IDE I'm using is Visual Studio 2019 Community Edition, which I'll leave a link in the description for. If you are having problems setting up the IDE, it would be fine to just use a browser compiler such as onlinegdb.com for the time being. But I may upload a video in the future showing how to download and set up Visual Studio. Anyways, so what I have here is a very basic but famous program. I'm sure you've seen printing Hello World everywhere, but I'm going to be using this to describe the general structure of a C++ program. Just a quick side note, but in this program you can see these like green text everywhere. What these are comments, which are used to make your code easier to read for yourself and others. Sometimes you're going to write a huge amount of code and then months later you won't remember what it does, so instead of like painstakingly tracing everything you wrote to understand it, you can simply leave a note for yourself in English. Comments are especially helpful whenever you're collaborating with other programmers, so if you're like having to edit somebody else's code, you can actually see what it does without having to like spend so much time like translating it, like what does this do, in order to just read each other's code. Anyways, 2 forward slashes lets you do a single line code like these, and then this format of /* comments / lets you do multi-line comments like this. And then up here we have our #include statements. Well, in this program I only need one, which is IOStream. This lets us use input and output, but in this case I'm just outputting hello world to the console. So the thing about #includes is that C++ has many libraries of code that give us access to functions, which we would need to explicitly tell the compiler that we want to use them. So if I were to remove this, so I no longer have access to output functions, so the compiler doesn't know what I mean by cout. Like that doesn't mean anything to it. It doesn't exist anymore. So if I put that back in, everything's fine. And then using namespace standard, or STD for short, is a statement I'm not really going to go too far into right now. Essentially all you really need to know is that it lets you use cout freely like this. Both of these contribute to this line, so these two are pretty important if you want to make console output. So also just to demonstrate, if I remove this, it doesn't work, put it back, it's fine. And then int main is where you'll start your actual code. The compiler will start reading at int main at the beginning right here in this little curly brace block. It's going to go through each line of code and execute one by one until it reaches an exit statement. In this case, return 0 is our exit statement. And like I said, these curly braces are required to pretty much show what the main function body is. So if I were to try to put any kind of like statement outside of the main function, yeah, it's already throwing errors. If I did this, yeah, it doesn't like that. It doesn't know what I'm doing. If I put it even before the main block, even though it's below the main header right here, because it's outside of this curly brace, it doesn't know what this statement is doing. Like, it needs to be in an executable like scope. And then we have the actual cout hello world statement. This hello world string is being sent to cout, which stands for console output, through these things called stream insertion operators. The ones pointing to the left are the ones for output. If you have the ones pointing to the right, that's for input, but we're not doing that right now. And so this means that everything here is being sent to console output. End-L is actually a function that creates a new line, kind of like whenever you're in a text document and you hit enter, it'll go to the next line. At the end of this print statement, I also have this semicolon right here. A semicolon is kind of like a period to a sentence, but for like a program statement. As a beginner, it is very common for syntax errors to happen because you're missing a semicolon, so definitely you don't want to forget to watch out for these. Finally, once you have your program written, we can run it with the green arrow. And there we go. That's pretty much it. That sums up the basics of what a program looks like. So the first real topic I'm going to be covering is data types and variables. A variable is something that we can store data in, such as a number, a letter, or anything you want. The first data type we'll be looking at is an int, which is used to declare an integer, so like any whole number. So to use a variable, we need a declaration statement. This is to tell the compiler, hey, I want to use this variable, so remember it for later. A declaration consists of a data type and a variable name. A variable name can be almost anything you want, but it is good practice to have something meaningful for the program instead of an int named integer. Obviously, all of these are just examples. Variable names in C++ can only contain alphabetical letters, numbers, and underscores, but it can only start with a letter or underscore. So you can't start with a number, and you can't have anything else like, you can't have special characters, so no exclamation points or question marks, and you can't have spaces. You have to use underscores instead if you wanted that. Also, you can't use reserved keywords, meaning you wouldn't be able to use anything that's already recognized as a keyword in C++. So for example, you couldn't have an int named int, because the word int is already recognized. You can't make it up yourself as a name. As you can see, these are all valid names because they either start with a letter or underscore. It is worth mentioning that because variable names are case sensitive, if you have int lowercase x and int capital X, these are treated as two completely different variables. And then these three down here are invalid because, well, this, like I said, this one starts with a 2, which is a number. You can't do that. And then this one contains a special character. Also can't do that. And then this one is trying to name int int, like I said earlier. Can't do that either. Obviously, there's other examples, like, actually, return down here would be another reserved word that you wouldn't be able to use. Yeah, so it doesn't like that either. You can't name a variable return. Also, even though this is just for ints, these rules apply for any data type. So if I wanted to create a double, which is a type of like decimal, so if I wanted to make like 2.4 a variable, any of these would also, like if I were to replace integer with double, if I were to replace int with double, all of these names would have the same like application. These would all work and these wouldn't. But yeah, that sums up declarations and variable names. After you've declared your variable, you can now program to do stuff with it. You can initialize a variable using the assignment operator. An assignment operator is just like a fancy way of saying an equal sign. So int I and then I equals 0 means that we are telling the compiler, hey, make an integer named I, and then set it equal to 0. Once we do this, we can do all sorts of operations on this integer. Also, it's worth mentioning that you can actually combine these two statements, the declaration and initialization, into one big statement. So if I did int I equals 0, this would also be valid. It's just combining the two together. It just depends on like when exactly you want to initialize your variables. First I want to talk about adding. These three statements are all equivalent to add 1 to I. So to understand exactly what these statements are doing, it's important to know what left and right operands are. A left operand is whatever is on the left-hand side of the assignment operator, and then the right operand is whatever's on the right-hand side. So the left-hand side, or like the left operand, is what we are assigning a value to, whereas the right operand is the value that is being set to the it's being set to the left operand. In this example, I would be the left operand, while 0 is the right operand. This means that I is equal to 0, or 0 is being assigned to I. And this is also why I equals 0 works, but 0 equals I doesn't, because 0 is an invalid left operand since it's already a literal number. You can't change the value of 0. It's like you can't change it. It's 0 is 0. You can't make it equal anything else. However, if we look at I equals I plus 1, it shows that I can actually be either a left or right operand, or in this case, it's both. This means that if I is on the left, it's being treated as storage space, but if I is on the right, it's being treated kind of like a literal number. So in assignment operations, the right operand is always evaluated first, and then it will be assigned to the left operand. This means that this statement, in chronological order, it's gonna look at I plus 1 first. Like it's not even gonna look at whatever is on this side. It's gonna look at this first, and it's gonna say I, which we said was equal to 0 earlier, and we're gonna take 0 plus 1. And what is 0 plus 1? It's 1. And then we're gonna take 1 and then assign it to I. So now at this point, I would equal 1. And then this next line, we have I plus equals 1. That's a really weird way of using an assignment operator, but it's just shorthand for this previous line. It's pretty much saying that whatever is on the right operand, we're just going to add it to whatever the left operander was, and then set it to that left operand. So in this case, you'd have I equals whatever I is equaling right now, which over here it was 1, so then we have I equals I plus 1, which would be 1 plus 1, which is 2. And this shorthand right here isn't just limited to addition. You can also have I minus equals 1, I multiplies equals 1, or I divide equals 1, and so on. And all this is doing is just you're either subtracting by 1, multiplying by 1, dividing by 1, and there are others too, but it goes on. So this next one is an even shorter shorthand of these other two. The main difference is that this is limited to only adding by 1, whereas in these two, I could put whatever numbers I wanted. These don't have to be 1. I could put 2, I could put 500, and this would just add 2 to I, and this would add 500 to I. But in this case, this will only add 1. This is called the increment operator because it increments integers by 1. Likewise, the minus minus operator would be the decrement operator, meaning it would decrement by 1, so it would just subtract by 1 each time. And so I don't know if this is clicked yet, but the programming language C++ actually contains the increment operator, C++. Since C++ is supposed to be a better version of C, it is incrementing C by 1 stage. So yeah, the language is a pun. On top of that, there is also a language called C#, which is supposed to be the language after C++. And if you look at the pound sign, you can actually see that, like, it kind of looks like four pluses coming together. So technically C# is essentially like C++++. You can't actually use the increment operator in this way, but yeah, it's just a little fun fact about the original computer scientist humor or whatever. On that note, I believe that sums how to initialize variables.